Question 1. Let A and B distinct real numbers. Find the values of x in terms of A and B if A cubed minus AX equal to B cubed minus BX. So here is the equation. So what you have to do is you want to find this x. So here we'll isolate x. So then for this region, send this one to the other side. This one over here. So it will be x minus ax is equal to minus a cubed. So then what is this? BA. So x is common denominator. مشترك عامل. So we write it this way. Then we divide both sides with b minus a. It will be 1 here. So it's x equal to b cubed minus a cubed is equal to, b cubed minus a cubed divided by b minus a. Now here we factor this polynomial by doing the special factoring formula. Now this and this day will make 1, so we will get, okay, so one thing, let's be careful, here's minus, so it has to be plus here, so remember this. The rule is this one here. And some of the students are doing it this way. This is the correct answer, so it will be D. Now a mistake here. Okay, I want to show you a common mistake. This is not true. This is a big mistake. Okay, so for x, okay, solve the equation for x. So this is the equation. So 2x minus a over a plus 1 equal to x. So then you have to isolate. So you have to say x equal to something here. But you have, so there's x here and there's x here. So you cannot, this is not accepted. So you have to have this x and here no x. So we want this. So then let's get rid of this first. Multiply both sides with a plus 1. Then there will be cancellation here. You have 2x minus a, which is ax plus x. Now, how can we get x here? So we send this 2x to the other side, and then we will have all x's together. X, and here no x. So this is okay. Now the next thing we have to do is minus a is equal to x is common factor, so you can write a plus 1 minus 2, which makes x times a minus 1. You see this makes minus 1. And then we have, how can we isolate x? We divide both sides with a minus 1. So this will make 1. So x times 1, which is equal to minus a over a minus 1. So look at the choices. We don't have them. So a, it's this minus here. You can bring it to here. And also you can bring it to to the denominator. So you will have a over minus a plus 1 x. X is equal to a over minus a plus 1, which gives you this one here. Now, which of the following is the sum of the solutions of this? So we write this one here. And then the next thing we can do here is, here we have x minus 1, we have x minus 1. Okay, there's a common mistake here. This is a mistake. Divide both sides with x minus 1. Okay, don't do it. You cannot divide both sides with x, so this will be a problem because we will lose one of the roots. So one of the solutions did. The correct way of solving this problem is to send this part to the other side and to make it equal to 0, because we have x minus 1 here and we have squared. So there are two options here. You can either expand this one. You can expand, and you can do this, and you can try to do such thing, x squared plus something equal to 0, and use the formula for quadratic formula. But here I will not do that one, because I see a shortcut here. The shortcut is there's a mushtarak amil here, this common factor, x minus 1, so which makes 2x minus 1 minus 1. So x minus 1 times 2x minus 2 minus 1, so it makes 0. So x minus 1, here we have two options here, x minus 1 equal to 0, or this one, which is 2x minus 3 equal to 0, and you solve it. This is x equal to 3 over 2, and when you solve this one, you got x equal to 1 over 2, and then, sorry, this is 1, not 1 over 2. So then we add both. So it says sum means you will add them. Let's solve this problem. If the real solutions of x squared plus 2x squared minus 2 times x squared plus 2x minus 8 is equal to 0 are, the solutions are a, the real solutions of a of this equation are a and b, what is the absolute value of a minus b? So let's solve this one. The first thing we can notice is we have this term here and this term. These terms, they're same, and one of them is taken square. So it's squared. So it's better we replace these with a new variable. Let's call it u equal to x squared plus 2x. So then now this becomes u squared minus 2u minus 8 equal to 0. And then after this, we'll get we can find a solution of this by using factoring or by using quadratic formula. Okay, here this is easy to factor, and this will give you u equal to 4 and u equal to minus 2. I mean, if you solve them, and then we will get x squared plus 2x equal to 4, and x squared plus 2x equal to minus 2. And then when you solve this one, it's x squared plus 2x minus 4 equal to 0. Okay, this will become 2x plus 2 equal to 0. Now we have two equations here. One, let's solve this one, x squared plus 2x minus 4 equal to 0. Now we can try to factor this one, but we will not be able to find a good solution. I mean, through the integers we cannot factor it. The factors of 4 is limited. 1, 4, 4, 2, 2. They will not give this one. So a guaranteed method is to use the discriminant method. So I use the discriminant method here. This is minus b plus minus square root b squared. B squared makes 2 squared here. Minus 4 times a is 1 times c minus 4 divided by 2a. So this makes minus 2 plus minus square root 4 plus 4 times 4, so it makes 20. So if you calculate this one, you will get this one as 20 and divide it by 2. So this will give you square root 20 is square root 4 times square root 5. This will give you 2 square root 5. And if you do the cancellations here, like 2 plus minus 2 square root 5 divided by 2, and you will end up with minus 1 plus minus square root 5. Because you see here 2, 2, 2. And then we will get 2 real solutions, which are minus 1 minus plus square root 5. These are real solutions. Now, are these the only solutions? Okay, from here, so it says there are 2 solutions, but let's check also the other solutions. Do we have other solutions for this equation? Now, if you try to do this one, it's the same thing, quadratic formula, use quadratic formula. So you use minus b, which is minus 2, plus minus square root b squared, which is 4, minus 4 times 1 times c is 2, and divided by 2, you will get this minus 2 plus minus square root minus 4. Yes. So we will end up with minus 2 plus minus 2i divided by 2. So this is not real. So these are not real solutions. So this part, we are not interested in this part. Okay, we are interested only for the real solution. So a turns out to be, okay, minus 1 minus square root 5. B turns out to be plus 1 minus, sorry, not plus 1. It's minus 1 plus square root 5. Then we subtract them. Subtract them. So minus 1 and square root 5 plus 1 minus square root 5. 1 and minus 1 will cancel out. And we will end up with negative 2 square root 5, which makes plus 2 square root 5. So this will be the answer. Now, if the following triangle is a right triangle, then A is, okay, in the right triangle, we have Pythagorean theorem. The Pythagorean theorem says A squared, the sum of the square of this and this side, should be equal to the square of the hypotenuse, which makes 6. So A squared plus A is equal to 6. Now we have A squared plus A minus 6 equal to 0, and this might give you minus 3 and then plus 2. Okay, is it so? No. Let's check. So minus 3, 2, minus 3a plus a. No, we don't want this. We want this plus a. So we change a plus 3 with this, and this one with minus. Yes, now it makes okay. And then a squared, so a plus 3 equal to 0 or a minus 2 equal to 0. We have 2 solutions, but here a length should be always positive in a right triangle, so we don't take this one negative, so it has to be this because the length is always positive. Now the equation ax squared minus 6x plus a has 2 complex solutions for x. Which of the following is a set of possible values for a? So this is all about the discriminant. So ax squared minus 6x plus a equal to 0 has 2 complex solutions. So what's the condition to have 2 complex solutions? If the discriminant of the polynomial is less than 0, strictly less than 0. So what is the discriminant here? Discriminant, remember this one, remember ax squared plus bx plus c has discriminant here as b squared minus 4ac. So if you apply the same rule here, the discriminant should be, now from here, the discriminant should be b squared. B is minus 6 here, so it has to be minus 6 squared. Minus 4 times a is here, and c times c. C is also a here. So it'll be 36 minus 4a squared. So it has to be bigger than 0. So, sorry, less than 0. So we need to solve this equation now. Because of this, it has two complex solutions if the discriminant is less than 0. So we have to solve this equation. Now let's remember the steps here. Okay, 36 minus 4a squared less than 0. And then you can write, so 4 is a common factor, so you can write it as 9 minus a squared less than 0, so you can divide by 4, and then you will end up 9 minus a squared is less than 0. Now, the next thing is we have to find the roots of this equation. Step 1, so it's standard, so step 1 is always make it standard, it's okay. Let's go to step 2. Find roots of 9 minus a squared equal to 0, or the solutions. Now when you solve this one, you can say a squared is equal to 9, which gives you a plus minus 3. So what is step 3? Step 3 is put them here, and then now check the for different values here, check the sign of 9 minus a squared. So if you pick a big number here, pick a minus 4 here, so you will see it's 9 minus 4 squared, so it's obviously negative 7, so it will be negative. And now pick here 0, so you put it here 0. 9 minus 0 squared is 9, so it will be plus. And take 4, so 9 minus 4 squared is equal to minus 7, so this will be a minus value. Now we made the analysis, sign analysis of the equation on the real line, and we want the negative we want the intervals on which the function is negative, so negative intervals wanted. So step 4 is we can write it as minus infinity up to minus 3 not included, and 3 to infinity, so 3 also not included, so we write, so the solution has to be this. So this is what we have in question 7. Which of the following is the solution set of this? Now let's look at this function. So basically, if we have a square root on one side, then we try to take the square of both sides. And 4x squared minus 15, which is equal to 4x squared minus, you can use the product rule here, the square rule. It's the square of this, and 2 times this one times this one, so it will be 20x, and then plus 25. Or you can do this. Square means multiply with itself. You can also do this one and get this one. Now after this, you get 4x squared and 4x squared. So Send this one to the other side and send all of them to the other side and wait. But let's see what happens if you send all of them to the other side. You have 4x squared cancel. You got this one, negative 20x, so 25 plus 15, it'll be negative 20x, negative 40, no, positive 40. And then you send this one to the other side, you get this. So x will be equal to 2. Okay, is it a solution? Is it fake? Okay, we have to check. It might be a fake solution because in the square root questions, we always should check whether our solution is a solution or not. So let's check it. You know, the bad thing about taking the square is this: if something wrong, for example, this is wrong, right? But when you take the square, you got the equality here. So this makes the problem. This is taking the square, even this is wrong. When you take the square, you get a correct answer, the correct statement. So we have to be careful. So we will put 2 here, check. So 4 times 2 squared minus 15, is it equal to 2 times 2 minus 5? So this part here is 16 minus 15, which is square root 1. Square root 1 is 1, but here we will have minus 1. Is square root 1 equal to minus 1? No. So this is not a solution, so there is no other solution. If there were a solution, it would be 2, and 2 is obviously not a solution, so the solution set is not, it doesn't exist, so it's empty set. The sum of the solutions of this is, it says the sum, so we will find the solutions, then we'll add them. Okay, how to find this one? When you have different fractions, it's better you get rid of the fractions first. So the best way is to find the LCD of these denominators, and if they're definitely wrong, definitely different, and there is no common denominator, you can directly say I'm taking their product as their common multiple. So then you can multiply both sides of the equation with this. Then when you multiply, you get x minus 6, and there will be this cancellation. You will get x plus 2. And if you do this one with these two, then because of the denominator, you will get 5 times x minus 6. And when you do this job here, you will get x squared minus 4x and minus 12. And this part will give you 6x minus 5 times negative 6, negative 30, negative 28. So that x squared minus 4x minus 12, and send them to the other side. Minus 6x plus 28 equal to 0. X squared minus 10x and minus 12 and plus 18 plus 28, it makes 16, which is equal to 0. And does it look factorable? Can we find the factors, or shall we do the quadratic formula? It depends on you. I would say here, if you have minus 10 and here plus 18, so I would go for negative 8 and negative 2, because their sum will be minus 10 and their product will be plus 16. So this is how I do it here. So I check minus 2 and 10. Okay, this x and x, they will make x squared, and minus 2 times minus plus 2, minus 2 times minus 8 plus 16, multiply them, you get minus 2x and minus 10x, so it is compatible with this. So factoring should be, the correct factoring is x minus 8 times x minus 2 equal to 0, and we end up with x equal to 8, x equal to 2, and then the solution. So then we have to check here. 8, does it make this one 0? No. Does it make this one 0? No. So 2 also doesn't make them 0, so they're okay. So these are the solutions. So 8 plus 2 equal to 10. Question 9. Sum of the solutions of this equation is what? Okay, now the first thing we can do here is to write this one as a power. So if you write it as a power, it will be x minus 1 to the 2/3 power is equal to 4. Now, if you have a fraction power here, it's a rational, okay, it's a fraction power. Then you take both sides 3/2. You flip this one and you take it as power, but you're doing it to the both sides. And here, since it's even, so this will be equal to the absolute value of x minus 1. Now, which is equal to 4, okay, 4 to the 3/2 power. Okay, what is this? Okay, this is indeed, it's equal to the square root of cube of 4th. So we don't have to write 2 here, it's just the usual square root function. So it will be 64, so which makes 8. So we have this equal to 8. Now, so x minus 8, x minus 1, the absolute value of x minus 1 equal to 8 means x minus 1 equal to 8, or x minus 1 equal to minus 8. This will give you x equal to 9. This will give you minus 7. So we can try this 9 and minus 7 here. You can put 9 here, 9 minus 1 squared cube root is it 4? So look at here, 9 minus 1, it's equal to 8. 8 squared, 64. Cube root of 64 is 4. That's correct. And let's look at the other option. It's minus 7 minus 1 squared, so which makes negative 8 squared, which is 64. And it comes to the same thing here. Yes, they're both correct. So then you add them because it says sum. So this will give you 2. Which of the following is the solution set of this inequality? Now this is an inequality, and in the inequalities we generally don't use LCD. So in inequalities, we generally don't use LCD method if there is x in the denominator. If there's x in the denominators. But here, as you see, there's no x here, so no x here. So then we can use the LCD method here. So in this case, we can use LCD because there's no x in the denominators. So what is the LCD of? The LCD means like the least common denominator, or Makam Mushtarak Asghar. So 3, 2, 6, we find their least common multiple. So it's like Mushtarak Asghar Mudaf. So it's 6. So then we multiply both sides of the equation with 6. And we get rid of the denominator. So 6, 3, it will be 2. So you got 2 times negative 2x plus 3. And then here 6 times 3, 18 over 2, which makes 9x. And 6, 6, they cancel out. We get 5x. Now minus 4x plus 6 plus 9x less than 5x. And when we collect all x's one side, then we get this 6. Here, there, it goes like 5x plus 4x. And then minus 9x. So we get 6 is less than 0, which is false. This is false for any x, So this equality can never be true for any x. So the solution set is empty set. Which of the following is the solution set of 3x squared minus x is bigger than or equal to 2? Now the first step is to write it in standard form. So here I will say write it in standard form. Okay, what does this mean? It means write it as bigger than 0. So make one side 0. Then the next thing is solve the, find the roots of x squared minus x minus 2 equal to 0. So you will find the roots here. Okay, one way is using the quadratic rule, and the other is quadratic formula, or the other way is to use the factoring. So we can factor it. Or, maybe quadratic formula. Okay, I will use quadratic formula here. X is equal to minus b, it's minus 1, plus minus 1 squared, minus 4 times a times c. So this I'm using this a, and b is here minus 1, and c is minus 2 here. So I use them here, times 3. So I got this one here now, 1 plus minus 1 minus 4, 3, 2, it makes 24, so it makes plus 24. So you see it minus and minus, so it will be plus 24. So it will be 1 plus minus square root 25 divided by 6, so which gives us 1 plus minus 5 divided by 6. So here it gives you one solution, which is 1 plus 5 over 6, which is 1. And the other solution is 1 minus 5 over 6, which gives us minus 4 over 6, and which is minus 2 over 3. Now this means we have two solutions, two real solutions. So one is x equal to 1 and the other is x equal to minus 2 over 3. Now the next thing is we should step 3, we can make the real line and put the roots here. Now after this, we take some values here. We take minus 2, for example. Let x equal to minus 2, and we know it's less than minus 2 over 3. And then we plug it in here. So it will be 3 times negative 2 squared minus 2, which is 12 here, plus 2 minus 2 will be 12, so it's plus. So we write here plus. Now we do the same thing for this interval, and take here, you can take 0, 0 is somewhere here, so I will take 0 and I'll put this here in the polynomial. 3 times 0 squared minus 0 minus 2, which is minus 2, so it is a minus value. So then, well, I will say this one is negative. And now when it comes to the last one, I can take again a big number, I mean bigger than 1, so it's 2. 3 times 2 squared minus 2 minus 2, it's equal to 12 minus 4, which is 8. So it's a positive number, so I will say this part is positive. So now step 4 is writing the solution. So the important thing here is it says bigger than 0. So this is important here. This is, okay, you will pay attention to this inequality sign. So this means it's positive intervals wanted, because it says bigger than 0. Bigger than 0 means positive. And then this part says the roots are included. So what is the positive parts? Okay, let's look at here. Positive parts, positive intervals are these, and also we need to include 1 and minus 2 over 3. So when we write this, the solution set should be is minus 1 minus infinity to minus 2 over 3, and this root is included, and the other one is 1 to infinity. So it will be B. Now, which of the following is the solution set of this? So which is x squared minus 2x plus 1 bigger than 0. This is in standard form, already in standard form. So step 2 is finding the roots here. So when you solve this one, it will be x minus 1 squared. So this is, it implies x equal to 1. And so this is the only real root. This is the only real root. Now step 3 is you make the real line here. It's 1 only. You put 1 only, and then you take numbers here. You take numbers. So take x equal to 0 and plug it in here. So you put 0 there. So you get 0 squared minus 2, 0 plus 1, which is plus 1. It's positive. So you say this has to be plus. Now take another number here, take x equal to 2, and it will be 2 squared minus 2 times 2 plus 1, which is 1, and then it will be plus 1, plus, so we write here plus. Now we finished the real line, And now the next thing we have to do is we have to write the solution set. Step 4. So when writing the solution set, you have to check this equal sign here, the inequality sign. It says bigger than 0. So bigger than 0, it means it will be positive intervals wanted, and there is no equal sign here, so there is no equal sign, roots not included. So then the solution set is everything here with all positive roots, but except 1. So we don't want 1 here. So it has to be from minus infinity to 1 union 1 to infinity. So it will be D. Now, which of the following is the solution set of 3x squared plus 2 plus x plus 1 bigger than 0? So in this case, we write step 1, it's already in standard form. There's no problem here. In step 2, we have to find a solution of this equation. So we find the roots of this polynomial. And here you can use the quadratic formula, a equal to 3 and b equal to 1, and then c equal to 1. And using quadratic formula is always, it works well. I mean, if it is hard to do the factoring, you can try. Then x equal to, sometimes you go, if there are very, very big numbers, you can try to do the factoring also, because sometimes it's hard to do the quadratic formula. So this is minus 1 minus plus square root b squared minus 4 times ac, 4 times 3 times 1, and divided by 2, and it gives you here minus 1 plus minus square root minus 11 over 2 times 3, sorry. So as you see here, this is, we have here, it's a complex number. So it's not real, because the square root of minus 1 is square root of 11i. So we will have I here. So these, the roots, there is no, so we have, there is no real root. So you see now the discriminant turns out to be minus 11, which gives you no real root. Then we say from here, we are interested in the real roots only. When doing the sign analysis, when solving the inequalities, we are interested in the real solutions. So there is no solution, real solution for sure. So in step 3, we have nothing to put here. So in this case, we don't put any solution, I mean, no root here, but still we do the same thing. We take any number here, take x equal to 0, and plug it in here. So it will be 3 times 0, 0 squared plus 0 plus 1 equal to 1, so which is plus. So in this case, you put plus everywhere. So then if there's no root, that means this is all positive or all negative. Just you have to take one value and see if it's all positive or all negative. So step 4 is you will check now this condition here. So this is what is wanted. This is wanted. So what is wanted? Positive intervals wanted. So roots not wanted, but we don't have any roots, so there's no problem. So roots not wanted because of here. So we don't have anything like this here. So we don't have this. So roots not wanted, and we already don't have roots. So there's no problem. So the solution set is indeed all of them, all positive intervals, so which is minus infinity to infinity. So this is A. Which of the following is a solution set of this inequality? In this inequality, there is this x here, so there's a denominator with x, so we don't use the LCD. I mean, if it was a number like 5 or 6, I would go with the LCD and multiply both sides with something. But in this case, we don't. First, in this type of inequalities, first you make it in standard form. So what does this mean? Is this subtract? Okay, send this one to the other side. You get bigger than 0. So this is what we want. But we are not done yet. We have to write this one in this form. Something divided by something bigger than or equal to. So we have to write it as a single fraction, right? It as a single fraction. So this is how you can do it. Now you have to know how to do the fractions here. Okay, there is no common denominator here. You just basically multiply the denominators with each other, and then you will get this 5 times x plus 3 divided by 5 times 3x minus 4, and minus 5 times 3x minus 4, and then negative 4 times, okay, this will be 4 times 3x minus 4. And when you combine them, you will get this 5x plus 15, negative 4 times 3x minus 4. You can combine them this way. So then you can multiply with minus 4 here. So you will get minus 12x. And when you do this one, it will get plus 16. Then it will give us 5x minus 12. It will be minus 7x plus 15 plus 16. It will be 31, and divided by 5 times 3x minus 4. Now this gives the standard form. Now everything is fine. Now the next thing we have to do is to find the denominator, the roots of the denominator and the numerator. So set the numerator equal to 0 and find the root. You can find the root by 31/7. You can send this one to the other side, you will get it. And here you can get the root of the denominator by setting this equal to 0, because when you divide by 5 you get this, and this will give you x equal to 4/3. Now we have two roots. The step 3 is to put these roots here. So this is about like a 4 point something, because 28/7 is about 4, and 35/7 is 5, so it's about 4 point something, let's say 4.3, and this is about like 1.3, something like that. So we have to put this 4/3 here, and here 31/7. Then now we have to, okay, this is about like 1.3, and this is about like 4.5 or 4.3, whatever. And we take these numbers here. Take a number here, take x equal to, let's say, less than 1, it's 0, okay? Less than 1.3, so 0, you would just have to put it here. So negative 7 times 0 plus 31 divided by 5 times 3 times 0 minus 4. You will get a negative number, positive number, positive 31. And here it will be 0, minus 1, minus 20, so you will get a negative number. You can say it's negative. And we can do the same thing for the other number. This is about 1.6, we said, no, 1.3. So it's better we take here something like 2. Okay, so negative 7 times 2 plus 31 divided by 5 times 3 times 2 minus 4, and which is negative 14 plus 31 divided by 5 times 6 minus 4. So which is, this is plus. And we know this is plus, so it will be plus over plus, it will be plus. Now the next thing here is we have to check the last one here. We can take a root here, like x equal to 10. Not root, take a number here. And when you put it here, minus 7 times 10 plus 31 divided by 5 times 3 times 10 minus 4. This is 30, so this will be a positive number. This is negative 70, 31. It will be a negative number, negative divided by positive, so it will be a negative number again. So then we have this question, this sign. Now, what is wanted? The last thing we have to do is this one, step 4. So positive interval is wanted. So it will be this. Now the roots wanted. But of course the rule is root of the denominator. Root of the denominator is never wanted. So we don't want it. So this 4 over 3 not wanted because it's making this one 0. This not wanted, but this is wanted. So it will be not included, but this one will be included. So we will have the solution set as this one, B. Let's look at this problem here. There's an inequality here, and this is a rational inequality, and in the denominator we have x. So since we have x in the denominator, we do not use the LCD approach here. We have some steps for solving such inequality. The first thing is you have to write it in standard form. What we mean here in standard form is this. Make it less than or equal to 0 and combine this part. Combine, what I mean here, write it as a single fraction. Write it as a single fraction. We did such exercises about write it as a single fraction in quiz 1, as far as I remember. Okay, now let's do this one. X plus x plus 2 minus x plus 2 over 1. So how can you do that? You multiply this one with x plus 2 squared, and then what you can do here is x minus x plus 2 times x plus 2 divided by x plus 2, and then this will give us, when you do this one, it will give us x minus x squared minus 4x minus 4 divided by x plus 2, and this will give us minus x squared minus 4 minus 3x minus 4 divided by x plus 2. Now it will give us this. Now if you don't want to deal with this negatives here, you can multiply both sides with negative, and it will change the direction of the inequality. So this will give us x squared plus 3x plus 4 divided by x plus 2 bigger than 0. Now we have this standard form, and after finding the standard form, we want to find step 2, the roots of the denominator and the numerator. This x squared plus 3x plus 4 is equal to 0, and we will solve the same thing for the denominator. And here, if you look at here, you can go with okay, how can you do it? So we can do it with the fraction with the quadratic formula. We can try to factor it, but it doesn't look factorable to me because this is plus here. There will be minus minus, so it's better we write the quadratic formula. The quadratic formula will say -3 plus minus b squared, which is 9, minus 4 times 4 times 1, so it will be 4 times 4 times 1, which makes a negative here, a negative number here. So this will be square root -7/2. And as you see here, we have a non-real. This is a non-real number. So this is complex. This is not a real root. So these are not real roots, but the only real root is coming from the denominator, which is -2. In this case, in step 3, when making the real line chart, we will use in step 3 -2 here only, -2. And then, okay, let's not forget what we have here, x squared plus 3x plus 4 bigger than 0 divided. Okay, we transformed this one to here, so we will keep working on this part here. So take a value here. Let's take x equal to -3 and put here. So we'll get 3x squared plus 3 minus 3 plus 4 divided by x plus 2. So this will give us what? It will give us -3 squared. It will be plus 9 minus 9 plus 4 divided by -1, which makes -4. So it will give us minus value. So you can say now this part is negative because of this here. Now the next thing, let's take x equal to, okay, one of the easy x value is this x value is 0 if possible. Okay, 0 is somewhere here, so take x equal to 0 and plug it here. So you will get 0 squared plus 0, 3 times 0 plus 4 divided by 0 plus 2, which makes 4/2, which is 2. This is plus, so you can say this is plus. Now so it comes to the last part here, the step 4. In step 4, what is wanted here? So this is wanted bigger than or equal to 0, means positive intervals wanted, and the root of here, root of numerator wanted if exist. Now it doesn't exist here, the root of the numerator. This is the root of the denominator, so we don't take it, but the positive intervals, so we have this part, and we don't want this. Okay, this is the denominator, the root of the denominator, never allowed in the solution. Do not ever include, so it means never include. So in this case, it will be -2 up to the infinity, so it will be this. Which of the following is the solution set of the inequality? So we solve the inequality. Again, we have this x's here, so we do not use the LCD. And then we directly do step 1, which is write this in standard form. So what it means is make one side bigger than or less than 0. So collect all terms one side. Then the next thing is you have to write it as a single fraction. So how can you do that? We have x, and here x minus 2. Then you multiply, you get 8x over x minus 2 times x minus 2 minus x times x minus 2. Then we do this, 6 times x minus 2, which is equal to, you can combine them now, x times x minus 2, and 8x minus 6 times x minus 2. And if you do this calculation here, you will get negative 6x plus 12. And this makes 2x plus 12. Now we can write this one as 2x plus 12 divided by x times x minus 2. Now this is in standard form, and then we will go to step 2. Step 2 is find the roots of the numerator and the denominator. So when you solve this one, you will get x equal to minus 6. And when you solve this one, you got two options here, x equal to 0 or x equal to 2. So you take both options here. You collect all options and you write all the solutions here, all possible solutions. Step 3, and you take these and put them in the real line, on the real line. So minus 6 is the least, so minus 6 we put, then 0 comes, then 2 comes, and now we take points for each interval. So take, for example, x equal to minus 10, or yeah, you can take minus 10, plug it here. So you got 2 times minus 10 plus 12 divided by minus 10 minus 2. So this here will give us a minus value, and this here will be minus times minus, it will be plus. So in total it will be a minus value, so you can say it's minus here. So then, so if you did some practice for this, I mean, if you practice enough, so you will get this ideas. Here's x minus 6, 0, get x equal to minus 1. So put it here again, and it will give you 2 times minus 1 plus 12. And minus 1 times minus 1 minus 2. And here it will be a minus number. This is minus, so it will be plus. And here minus 2 plus 10, 12, it will be 10, so it will plus. So plus divided by plus, it will be plus. So we write here this one, plus. And we do the same thing for the other intervals. And you can put here 1 here, x equal to 1, and this will give you 2 times 1 plus 12 divided by 1 times 1 minus 2. So it's a plus divided by minus number here, so it will be minus. So we write here minus, and you can do the rest as by picking a number here, x equal to, let's say 5. Let's see what happens. 2 times 5 plus 12, it's positive here. And 5 times 5 minus 2, it's positive, positive, it's over positive divided by positive, so it's positive. Now, the next thing we have to check is this inequality sign here. It's less than 0, so less than 0 means negative wanted, negative interval is wanted. So we want this intervals. And what about the equality? So the equality will tell root, or the roots of numerator should be in the set in. So what is the numerators? What is the 0 of the numerator? So numerator is this. So -6 is the 0 of the numerator. So we take 0 -6. So this is included. So it will be all up to here. But this is not included. This is not included. So because these are the zeros of the denominator, so it has to be this one. Now let's look at the solution set of this problem here. So we have x cubed, x squared, and x, and bigger than 0. So it's already in standard form. The only thing left here is to find the roots of this polynomial. So you set it equal to 0, and you try to get the roots here. So this is x is a common denominator. So you have x squared plus 2x plus 2 equal to 0. And we have two cases here, x equal to 0, or this whole thing is equal to 0. And you can try to solve this one. I mean, you can go by factoring, but here I don't see a factoring. It's +1, +2. I mean, if you add them, you don't get this. If you take the minuses, we don't have minus here. So we cannot use factoring. It's better we go with the quadratic formula. It is -2 plus minus square root b squared 4 minus 4 times 1 times 2. So it makes 2 times 1. So it will be -2 plus minus square root -4. So this is -8. So it will be -2. Okay, no need to go further because we are interested when solving the inequalities. We are interested in the real roots. So this is not real. So we will end up with, square root I for I. So this is not real. So we are not interested in the complex roots. So the only real root is here. And this is the root of, this is a polynomial. Okay, there's no problem. And then this is the only root. So we say the only real root is x equal to 0. Step 3, we take this root and put it here. You remember that if there is no real root, you don't put anything, you just skip the step. And not skip, sorry, you don't skip, you just take a value and determine whether everything is positive or negative. Now you take x equal to -1 and put it here. You can do it. -1, and this is +2, and it's -2, and this will make minus, so it will be minus. So you can write here minus, and you can take any value here, like take 5. So here it will be 5 cubed plus 2 times 5 squared plus 2 times 5. It's definitely a positive number because there is no negative, so you can say it's positive here. So then go to step 4. So step 4 is saying, okay, what is wanted? So look at here, or look at here. So it's bigger than 0. So it means positive roots, positive intervals wanted, and no root, or roots are not included. So because we don't have this here, so we don't have this. So where is this positive interval? So it's here, and 0 is not included, so it has to be 0 to positive infinity. So it's this. Now, which of the following is a solution set of this inequality? So we have, okay, we have to do this step by step. Step 1 is, okay, step 1 is easy because it's already less than 0. So we have zeros here, so it's okay. It's in standard form. Now step 2 is find the solution of this product. So how do you solve such thing? So since this is product, the only way to be equal to 0 is one of the factors should be 0. So we have two options, three options here. Either we have this one 0 or this one 0 or this one 0. So we will check all these options. So here, when you solve this one, you will get x equal to 1, because if square equal to 0, then it should be 0 inside. Here, it gives x equal to -1. And when you try to solve this one, okay, let's try to solve this one with a quadratic formula. It will be -1 plus minus square root b squared, 1 squared, 1. And this is 1 is here. So then -4 ac. A1 and C1, it will be 1, 1. So this is, we end up with 2 times 1. Plus minus square root -3 divided by 2. Now the square root 3 here, square root -3, not real. So square root -3 is square root 3i. So this is not real. So these roots are not real. So the only real roots are 1 and -1. Step 3, put them on the real line first. And smaller one and the big one. Okay. And then you take numbers here. Okay, take x equal to, let's say, -2 here. So you will put it here. So you will put it here. -2 squared plus -2 plus 1, which makes 4. -2 plus 3, it's +3. And then square, if it's square, so it has to be positive for sure. You know, square of anything will be positive. And then -2 plus 1 is for minus. So it will be plus, plus, minus, so it will be minus. Okay, between 1 and -1, we can pick here x equal to 0. And when you put this here, 0 squared, 0 plus 1 times 0 minus 1 squared, and 0 plus 1. This is 1, this is 1, and this is 1. So we end up with a positive 1 here, so it will be 1 positive. And take x equal to 2, and you can put this here. So this always positive here, and this will be positive here. So this will be also positive because, you know, you check them. This is clearly positive. This is clearly positive because of 2 here. And this is clearly positive. This is all will be positive. So you can say it's positive here. So we have we completed step 3, and the next thing we have to look is the inequality sign. So we want this. So negative intervals wanted, and also the roots, because of this, roots included. So where's this negative? It's here, and -1 included, but it says all roots are included because this is a polynomial. So all the roots. Where is the other root? It's here. This one also. So all roots are included. So this part union only this single set. So single point set. So this is the solution. Now let's solve this one. So step 1, make it in standard form. Okay, how do I combine? I will say x minus 2 here, and I multiply. So I don't see any common factor here. So for this reason, you can directly take this one, multiply and multiply. You got 16 over 2 times x minus 2 minus x minus 2 divided by 2 times x minus 2 less than or equal to 0. And 16 minus, okay, I will combine these. Okay, be careful about this. This, when you try to make this one to minus here, when you're combining it, the best way is to use the parentheses. I always emphasize it, but please half of the students, they do this mistake. I mean, they don't put the negative parentheses here, and they get the wrong answer. So what is this? This is 18 minus x divided by 2 times x minus 2 less than or equal to 0. Okay, next step is what? The next step is find the roots of denominator and the numerator, set them equal to 0. You will get x equal to 18. This is for the numerator, and this one will give you x equal to 2. This is coming from the denominator. Okay, step 3 is we put them here. 2 is here, and 18 is somewhere here. And then we will take values. Okay, we will take values from each interval. Okay, take this value. I will say take 0 here, x equal to 0. And you will put it here. So when you put it here, 18 minus 0, 2 times 0 minus 2, which makes 18 over minus 4, which makes my minus value. So you take minus here. And then take a value here. I will say, let's say 10, for example. Take x equal to 10 and plug it in here. So it will be 18 minus 10 divided by 2 times 10 minus 2. So this is positive and positive, like 8 here. This is a positive number for sure. You take plus. And if you take a big number here, like let's say this 20 here, so what happens? 18 minus 20, it's a negative number, and 18 minus 2, it's negative divided by positive, so we will get a negative number. So we got negative. So then next is to write the solution set, and what is wanted here. So you check this one here. Negative interval wanted. Negative interval is wanted. And for the rationals, this means the root of numerator wanted. What is the root of numerator? So it's 18. 18 will be included for sure, and the negative parts. So negative will be here, and we do not include the zeros or zeros of the denominator, never included. So we include this part plus 18 and not 2, but this part. So it will be from minus infinity to 2 and 18 to infinity. Okay, now there is one. Okay, now we have some linear inequality, I guess. So let's check. 12 minus 3x Okay, so get rid of the parentheses first and try to collect all x terms one side. I would just send these two guys in here and then this one to other side. Okay, negative 7x, it will be plus 7x here. And negative 3x, I can put it here. So 12 goes to the other side. And we have 5x bigger than, no, this is 4x bigger than minus 6. And what does this mean? Divide by 4. So you got x is bigger than or equal to negative 6 over 4. And if you simplify this one, it will be negative 3 over 2. Simplify by 2. And then it will be x bigger than minus 2 over 3. Minus 3 over 2. And it will give you the solution set as all the values starting from negative 3 over 2 to infinity. So it will be this. Okay, now we have this type of question. It says, which of the following is the set of the values of x that satisfy these two equations? And here it says and. So and is, if we see and, so we will solve this one. We will get the set here, the solution set, and then take the intersection of the solution sets of both equations. Now here, we have, okay, let's solve this one. So it will be 3x minus 3 bigger than 3x minus 4, and it makes, okay, send 3x here, send this one here. It will be 3x minus 3x is bigger than minus 4 plus 3, and which makes 0 bigger than minus 1. What does this mean? This is always true no matter what x is. So the solution set of this one will be minus infinity to infinity. So for any x value, this is true. So it means the solution set will be all real numbers. So the solution set here is minus infinity to infinity. Okay, now let's look at this one here. So here there's 2 and there's 1. So since we have 2, we can get rid of the denominator. There's no x in the denominator, so we multiply both sides with 2. And 2 is positive, so no problem with the direction of the inequality. So we have x bigger than 4x minus 12, and 4x you can send it to the other side, or no, let's send this one to the side and this one to the other side. So it will be 3x divided by 3, so we will end up with x is less than 4. So this gives you the this set here, minus infinity to 4. So from here we got minus infinity to 4, and from here we have all real numbers. So what do you get when you intersect them? One thing you can do here is, like, if you have difficulty in seeing this, you can directly put this in as a real line. So this is minus infinity to infinity, and this one put it also on the real line. This is up to 4, so 4 is not included. You can go up to here. And so which part is it? It's this part, this one, and this one is all of it. Now the question comes here. So intersection means the common parts, mushtarak. So what part is mushtarak? It's here. These parts are mushtarak, but there's one exception. 0 is not mushtarak, and these parts are not mushtarak. So the intersection will be minus infinity to 4. So only this part, but not 4. 4 is not included, you see. Which of the following is the set of the values of x that satisfy these two inequalities? But it says this inequality or this inequality. So when solving this exercises, we find the solution set of this, and then we take the union of the solution sets of these inequalities. So then let's find the solution set of this inequality. Now here we have two. We can, okay, in the inequalities we do not, I mean, we can multiply both sides with a number, okay, but if there's x here, don't do it. So this is different. So if it's 2, it's okay, but in the denominator, if you see only the number in the denominators, it's okay. You multiply both sides with 2 and you get rid of the denominator. This is okay. But if you see some x here, do not do this job. Okay, do not follow this procedure. So this is x minus 1 less than 2x minus 3, 6. And send it to the side. It will be x, 2x minus x. So send this one to this side. It's 5. And 5 is, x is less than 5, which means minus infinity to 5, and 5 is not included. And for this part, we can do the same thing, multiply both sides with 2. 2x bigger than x minus 5. And then x goes to here. X is bigger than minus 5. And it will be minus 5 to infinity. Now you take the union of these two sets. Okay, now what is it? Now if you want to see it, okay, if you cannot see it, you can do it this way. Like first make this one minus infinity to up to 5, which is this one. So not included, 5 not included. And do this one here. It will go up to minus 5. And it will be minus 5 to infinity. So infinity is here, right? So then the union means, like, you take all the red parts. So all the shaded ones here. In the union, you don't take the mushtarak. You take all of them. So this is not included, but it's here included. It's okay. So you take all of them. So all set should be minus infinity to infinity. Now let's look at this problem here. We will solve this type of inequality. We have 3. We don't want this 3 there, and since there is no x here, it's okay. We can multiply all sides of the equation, I mean all sides of the inequality by 3. And since 3 is positive, so it doesn't change the direction of the inequality. So 3x minus 6 less than 6 minus 3x, and then This will make 3 plus 3x. Okay, now what to do? Here, I want x only here, if possible. And I don't want 3x here, 3x here, so it's better I subtract 3x from all of them. And that will give you -6, 6 minus 6x, and 6. Then you can subtract 6 from both sides. So I don't want this 6. Subtract 6 from all sides. Subtracting or adding does not change the direction of the inequalities. So we have this -12 less than 6. Okay, I think I forgot this part here. This has to be equal. Okay. No, it is 3 here, sorry. This has to be 3. So 3 minus 6, it will be -3. Then we have this. Then we have to isolate x. So how can we isolate x? We divide both sides, all sides with -6. So then when you divide both sides with -6, then you change the direction of the inequality. This makes 2. This makes x. This makes 1 or 2. So which is, okay, I forgot the inequality part again. Yeah, this here, I forgot this one. So it will be 2, 2, no. The small one is always comes first on the left. So it's 1 over 2, 2, 2. It's this. One other way is this, you can solve this one. You can solve this one, you find the sets, and then take the intersection. So it means and. Use and here. Which of the following is the set of the equation? Okay, let's try to solve this one.